Alright, welcome to episode 7 of solving some Rosetta code problems in Mathematica. I've selected here a bunch of them and let's see how many we can solve this time. So let's start with this exercise. So find decimal numbers n that when converted to hexadecimal produce a number that uses the same set of digits regardless of order and ignoring duplicates as the original number. N smaller than 10 to the power 5. So 2339 is 923 in hexadecimal. And the set of digits used, ignoring order and duplicates, is 239 in both cases. Okay. So, base 10, 16, same digits, Q, I will call it. And well, it's pretty straightforward because we have integer digits of n and base 10, and then we do the same in base 16. And should it be a subset or should it be? That should be the same. So what I will do is I'll take the union. Should I do union? Yeah, so the union of each of them. So this will remove the duplicates and will sort them. And then it's a matter of just equaling them, I think. So let's see. And then select from range 10 to the power 5 minus 1. Let's see. Some people include 0. I guess that is fine. I'll take column yes. That is it. Now I have to open my special notebook. I hope it's still here. Yeah. Let's copy this header, paste it in place, copy this result. So note that multi-column by default will select basically as many rows as columns. That is the default, which is fine for this case. I mean, it will choose the closest one if it's not exactly a square number. Okay, let's submit this. Just to check. Looks all good. First one done. Alright, smallest square that begins with n. Find the smallest decimal integer square that begins with n. Alright, do I want to save this? Code is quite easy. Let's just do this. So I think maybe the opposite is more easy. Let's say, well, let's call max equals 49, and then we have what is the easiest? Let's just do this. Results equals empty association and can I do it like that? Let me see. Yeah, I think that's the easiest. So we just let it all go on to infinity. And well, the square is I squared, That's not so. And then we do integer digits of a square. And then does take, does it do up to? So we want to do the log of integer length max len 2. And then we take from integer digits up to hash and slash at max len, a range. So 1 to this, and then delete duplicates just to be sure. So these are starts, and then for each start, so we iterate to the starts, and then okay, what I should do is convert each of them to back to integers. So here we do from digits, if I recall correctly, yeah. And now what I do, if key exist q results comma s. Well, if it doesn't exist, is there a key? Yeah, that's fine. If it doesn't exist, then what we want to do, associate to, I think, is to append. Yes. Results equal s is I. If length results, well, I want to select from those less equal than max. Here we go. If the length of results equals max. Break. Let me save this because I have a feeling this might not work in one go. Smallest square starting with n. I should only keep the square number. So if we do values, I can do this. This is exactly what we want. So what I did now, rather than going every n, going over check the first n, just the first square that is n equals 1, and then for n equals 2, equal 3, equal 4. What I do, I go over each square and then just fill in whatever n I find until I, if it does not already exist. So this is the smallest one. So let me just go to the third last. Yeah, so it's perfect. So all these dynamics I don't need, and this one I don't need. So this is basically instantaneous. Yeah, we can do it in a column. Oh. Here we go. And it runs very fast. That's also good news. Here we go. Let's add this code. Copy this thing. Oh, I did copy as I should do this. There's indentation. Blob. And then here, copy this as plain text. Here we go. This is a fun little problem. Sort the primes. Let me see. Yeah. Sort the primes from a list to a list. What does that mean? Show on this page a ascending ordered list of primes from this given list. Okay, that seems very easy. So say we have this list. So the brackets are slightly different in Mathematica. What we just want to do is to select which are prime, and then we want to sort the result. Okay, well, let's just make it a one-liner kind of thing. So we don't even have a variable. We just do this. Well, then we just add sort around it. Here we go. Okay, I don't know exactly what the programming challenge or what the idea behind this challenge is. But yeah, it seems a bit trivial perhaps. At least Mathematica. If you would have to do this in C, then it would definitely take you quite a bit of more time because you have to make a prime check as if I don't have, as if I have infinite time. Alright. Product of divisors. Given a positive integer, return the product of its positive divisors. And what do people output? The first bunch of numbers. Okay, so we can do divisors. And then apply times / add range 30. Is that what they want? We do 50 here. Well, we can do 50. Boom. Here first 50. I missed that. Okay, these are not so challenging. Could do a multi-column here, but well. Find adjacent primes under 1,000,000 whose difference bigger than 36 is a square integer. So do we get pairs then? Yeah, okay, so let's find the primes below 1,000,000. Okay, this looks a bit funny now. So these are the primes, let's say. And then let's partition this. So now we have pairs of primes. And now we want to select from those where the difference is. And then the first one is greater than 36. So let's see how many we have here and how many we have here. Okay, that's already a huge reduction. But now we have to do another filter where if you take the square root, it is an integer. $26 only. Maybe I do it a little bit differently. Here I do number 2, and here's the difference. Because then I don't have to do this and this every time. I can just do extract or extract 3. Well, I don't need this statement anymore, and I don't need this statement anymore. So I take the third element, which is this difference here, and then I check if it's bigger than 36, and then I take, if you take the square root, that it is an integer. So that basically means it's a square number. Alright, this goes here. So let's copy this code. Save this. Take some water. Boom. Right. Longest palindromic substrings. Let given a string S. That's very good English. The goal is to find the longest palindromic substring in S. Longest, how do you call it? Palindromic substring. There's some subsequence. Maybe I'll call it that. Longest common. Yeah, I think this is a better thing. Let's call this a list. So I think that will be nicer. And then I can of course put the characters of a string in there. This will work on a general list. So let's save this. So this will probably be a little bit trickier. So, how to do this? I guess for each position, I just check it is a palindrome or not. With a minimum starting length of, I guess, 3. If you have a string of length 1, then it could also be just thinking what to do. So for odd length palindromes, it's quite easy. But for even, it's less clear how to do that. Because then there's no center cell. So here we have a palindrome, here we have a palindrome, but not here. And here we have a palindrome. But there's no even one. Okay, so I can add a few more digits. So two adjacent, is that a palindrome? Well, I don't know. Something like this. So then this is a palindrome and this could also be a palindrome. I guess find sequence, sequence position. L, where we have XX. Does that work? Oh, I have to define it. Even pos. What's this? Odd pos. Basically from these starting positions, I just basically broaden it until it's not palindromic anymore, or I hit the edge of the length of the sequence, let's say. Basically I can treat these things the same. Catenate. I can use join maybe. There we go. I think I should make expand subsequence try. I don't know. Let's call sequence, which is a list, and then some begin position, which is the form AB. So take M to N, great. It's not a palindrome. Well, it should be a palindrome, so I don't have to test that. Len equals length of sequence. max broaden equals, well, it's either a minus 1 or length minus b. Yeah, length minus b. Right. Is it correct if it's 16 and 15? Yeah. Do. Let's call J goes from 1 to max broaden if take sequence A minus J, B plus J, palindrome Q, then break. No, if it's not a palindrome anymore, then break. And then here we want to do, so last equals J minus 1. And here we return A minus last, B plus last. Let's make last a local variable. So what we do now, so 13, okay, I have to do take sec, bool, and slash add percent. Subsec, that seems to work quite nicely. This is the case where all of them satisfy, so that's why I initialize with that. But if that doesn't work, it will be cut off before. So that's why it does now work, and that works very nicely. So what do I want to return? These will be the subsequences. Yeah, so this will be, let's call these longest subsequences, let's say. Well, subsequences is fine. And then do that here, such that this function will immediately return all the palindromic subsequences. I think this would also be nice to add to the Wolfram function repository. I will consider that. Well, in principle, this is, well, fast enough, let's say. All right, let's contribute it. They want to do it with strings, which is well, fine, I guess. This is Yeah, okay. So let's well, this is now written for this, but what we can do is also S1. Should be L, huh? Here we go. You should only the longest one. That is I think we'll just do it like this. No auxiliary variables. I'll just provide these examples that they also do here. It's also good to see what it does with single characters. If there's no right. If sub length of subsex is bigger than 0, this. Otherwise, just don't return anything. It's not really given what is a palindrome, but I guess one character I don't consider a palindrome. I think that is a fair statement. If you wanted to include that, then well, you just do y here basically, which is a bit silly, I think. So I'm gonna go a different route than what some of the solutions here did, because I think that's not a palindrome. Well, let's remove this one because I think it's a silly example. Or I can leave it and then it's just empty. I can just copy it actually. All right, save this. Do I want to do more? Maybe. Well, I almost have to leave. Okay, let's leave it at this for now. Thank you all for watching. Next time I will continue with some more. I have many more here still remaining, and hope to see you the next time. See you later.